Hello everyone, this is Lawson, and in today's video we're going to be going over the prototypes in relation to the documentation that I have provided in the GitHub project. So first we are going to be concerned with the prerequisites. We are going to need Python 3.10 or higher, as well as SimEngine installed. So what I'm going to do is I've already downloaded this file onto my desktop, and we're going to go over some of the examples here in the notes. So how we would do that is we would go to the directory where our prototype file is, and we would use Python. We would import the file name, which if you can recall here is DAG. Once we've done that, we can go to the prototype itself, copy this code right here. And this is just a quick instantiation so that you can see the results for yourself. You can see that this result matches up with this result, which is the multinomial expansion. We can continue forward with this example as well, which is the third derivative of a product of two arbitrary functions. And then this is the predefined Bell polynomial example. And this is all thoroughly explained in the documentation here in a non-mathematical way for others to understand. If you would like to understand more about the prototypes themselves, I would definitely recommend these two articles. And then with this example, we have the convoluted partial Bell polynomial, which results match here as well. So now we're going to look into the prototype code and understand how the prototype is a proof of concept for objectifying reason, operationalizing it, as well as integrating context. And these three factors are also important in understanding how a domain-specific language for universal reasoning would be constructed. Objectifying reason takes place through combinatorial layering, which is described here. And within this combinatorial layering process, there is an ordering and pruning function. And this ordering and pruning function is considered the pot generator function. These are the definitions of the pot generator function. What's interesting about the pot generator function in these prototypes is that they do not integrate context of what we are doing with the prototypes at the pot generator level. This goes into how pot generators can be dependent not on context being integrated through the pot generator, but how it can be integrated through operationalization of reasoning itself as an object. So this goes into the concept of how the fluidity between reasoning objectified with the pot generator and the combinatorial layering will be influenced by the context integration and the operationalization of the reasoning itself. So once that we understand briefly the objectification of reasoning through combinatorial layering in the pot generator function in the prototype, how does that influence operationalization? Well, you see, the pot generator function in this reasoning unit is going to be based on the idea that we are going to be collecting on a layer. And these two collect from layer functions are separated based on the need for context integration, which we will go into in the context integration segment. But here, what we're worried about is how collecting from the layer influences the pot generator, because you see, rather than path transversal, which is how all the previous documentation leading up to this has considered operationalization, here we are considering collecting on a layer rather than the path. So collecting on a layer considers evaluating all of the combinatorial potential outcomes at this combinatorial step and performing an operation on that layer, which can be understood when you look into the code of the prototypes itself. But from what we're considering right now, the operationalization based on the pot generation took place because we are considering reasoning through the lens of collecting all of the combinatorial objects here, rather than choosing a path through the reasoning space. So we are performing an operation on the layer format. This goes to show that there is multiple different operations in reasoning beyond path transversal. And this prototype is not only a proof of concept of reasoning objectified and operationalized, but it also shows that operations can go beyond simply path transversal, despite there not being a domain-specific language catering towards reasoning being objectified. Another important thing to consider within the prototype is that with this operationalization, we have an example here where the convoluted partial Bell polynomial is actually dependent on the composing the predefined Bell polynomial reasoning proof object here. So this also shows that reasoning is not only objectified, but it can be composed. So as you can see from up here, this is why there is a separation of the predefined Bell polynomial proof object and the composition. And if you actually look closely, the only difference is that this is returning the results of the proof object, while this in itself returns the proof object. And this goes to show how the rigid parameterization within Python can be an issue when you're working with the reasoning being an object and a first-class citizen. As previously mentioned before, there is also the context integration. So the context integration is not happening at the pot generator function level here, but rather during the operationalization of the reasoning object. These are actually combinatorial primitives for the pod generator. So these don't actually describe any context, but rather the skeleton of combinatorics itself for which the structure emerges. The collection of the layer integrates a term function, a subdag function, a collection function, and a transformation function, which is the context integration based on the combinatorial skeleton. The difference between these two, or the collection of the layering and the collection of layering which is root dependent, is that the context integration in this Python prototype is dependent on, for instance, the composite reasoning one requires the collection here to have a different context integration. Otherwise, if you look in the examples that we had here, this is an f sub 0 and this is an f sub 1, and it's convoluted based on the structure. The context integration for the 0 and 1 denomination of these functions occurs at the layer collection and is based on the root of the proof object. And that's where we get the integration of the context, such as if this is going to be arbitrary function 0 or arbitrary function 1. And this is a matter of a difference in context integration. In a domain-specific language, this would be more considered due to having to balance the trifecta of objectifying reason, operationalizing it, and integrating context. Hopefully, throughout the prototype code, you can see how the rigid parameterization of Python and these other languages restricts the ability for free flow sandbox sort of construction and testing of reasoning in the way described here. So in the end, hopefully this video has properly articulated the balance and the fluidity needed between how we objectify reasoning, how we operationalize it and integrate context into it, as well as how this is going to help with understanding how we formulate a domain-specific language for which this reasoning object can be manipulated properly to enable automated systematic exploration and discovery of reasoning itself. And it can be understood that considering that we haven't really even considered path transversal as an operation with these proof objects, it is still possible to look through the object in terms of path transversal. So it's systemically emergent that other operations on this reasoning object may yield nonlinear outcomes, which is the potential beginning of a new emergence of science based on the objectification of reasoning. And we can go further into this in the documentations where I describe how chess can be approached as creating a reasoning space where machine learning can be utilized to create models that would overfit the chess reasoning space. And I would love for you all to go and look through the documentation further, because I believe that we together can build reasoning and create a world that we, as of now, can only dream of understanding.